Attack on Titan has quickly become one of my favorite TV shows as of late. The premise of the story: Titans, massive humanoid creatures, have taken over the Earth, pushing humanity to the brink of extinction and forcing them to hide behind massive 50-meter tall walls. Titans themselves are very powerful creatures, hell-bent on eating all humans. They are immune to conventional weaponry, as their only weakness is an ape. As such, humanity has opted to use omnidirectional mobility gear. This gear allows the user to basically fly around, as long as they have something to grapple onto. This also leads to some wacky physics, as you see many times just how ludicrously fast people travel. My final project will be exposing just how deadly the ODM gear would be in real life. This is the physics of Attack on Titan.
Levi. 大きくなったか?
In order to find the amount of force the ODM gear can exert, we need to find a scene that has a reference point that we can use to find velocity, in order to calculate impulse. There wasn't a single scene that had a clear reference. That was until last year, where our good old pal Levi gets blasted and chased down by a group of thugs. In this high action-packed scene, we get a nice view of the surrounding city. The chase leads to a straight road, which allows us to find the rough distance traveled, where we see Levi pushing the ODM gear to its full limit, go from full speed to 0 in 0.23 seconds. But how do we record how fast Levi is going? Well, we can do that by watching this one scene very closely. By using the houses next to Levi, starting with this one, we can estimate how far Levi is traveling. Levi passes 6 houses plus a road, which we will assume to be around the same length as another house. Attack on Titan cities are based off of the real-world city of Nordlingen, Germany. After some digging around, I found this house in the city, which looks strikingly similar to our first house. Using this as a rough estimate for the houses, we get each house being about 34.6 feet long, or about 10.5 meters. That means Levi's traveling a distance of 207.6 feet, or 63.3 meters, in about 2.3 seconds. This gives us an average velocity of 31.18 meters per second. Next, we need to find the mass of Levi and his ODM gear. Levi is canon to have a mass of 65 kilograms, and while there is no canon weight for the ODM gear, this real-life replica of the gear weighed about 10 kilograms. This is a conservative mass, as the actual ODM gear has fuel and wires for grappling hooks, but this is a safe estimate. Now, using the impulse equation, we get the value of force to be a value of 10,036 newtons of force. This is an absurd amount of force to be applied on Levi in this one moment, enough to break even his toughest bone, the femur, which only needs 4,000 newtons of force to break. Most, if not all, of Levi's bones should have been broken from this landing. In the next scene, we see Levi again swinging around the city. This time, Levi starts accelerating, which allows us to see how quickly the ODM gear moves the user. Again, we need to count how many houses Levi passes in a given amount of time. Assuming that our first house still measures up, Levi again travels 63.3 meters in 1.23 seconds. Now plugging in 51.5 meters as our velocity into the impulse equation, we get a value of 3,140.2 newtons of force. While nowhere near as deadly as the stop he had earlier, since most of the force is concentrated onto his upper hip and lower back, it is just enough to fracture his spine, which only needs about 3,000 newtons of force to break.
合図だ。
We haven't talked much about Titans though, have we? Let's fix that. Never mind that Titans somehow release energy when creating mass. Never mind that the catalyst for this reaction is biting their hand. And never mind how stupid this Titan looks. We are here today to talk about the Beast Titan and his amazing throwing arm. In this scene, the Beast Titan throws a barrel that contains a human inside. He's throwing it past Wall Maria and into the Shiganshina district. To calculate the amount of force that this throw would take, we need to find out how much time passes for the barrel to reach its highest point in the throw, and how far and how high this barrel travels. Let's start simple. How long it takes for the barrel to reach its highest point? This is hard to find, as it appears at 15 seconds, the barrel is still rising, while at 23.5 seconds, it appears to be falling. So we will take the median of these two times, of 19.25 seconds. Next, how high the barrel is being thrown. Wall Maria stands at 50 meters tall, and the Beast Titan stands at 17 meters tall. So at minimum, the barrel is being thrown 33 meters high. Now for how far? Well, from this high shot of the area, the Beast Titan, who should be standing around this area, throws the barrel to what appears to be this white building. So we need to find the distance, and then half it to find how far the barrel was thrown at its highest point. To do this, we need to look at the three great walls of Wall Sina, Wall Rosa, and Wall Maria. Wall Rosa and Wall Maria have a canon distance between the two of 100 kilometers. Using Photoshop for pixel measurements, we can make a proportion of pixels to kilometers, giving the Shiganshina district a distance of 47.5 kilometers. We know that there is a city area past the walls, and a little farther is where the Beast Titan launches the barrel. Using the same method, we get this area to be about 24 kilometers. Now we can use pixel measurements again to find the rough distance of where the beast is to this white building. This gives us a distance of 48 kilometers, the peak being somewhere around 24 kilometers. Now we can finally find the average velocity both in the y-axis and the x-axis, combining them to give us a velocity of 1,247 meters per second. I don't like where this is going. Again, we need the mass of the object. The human inside the barrel has a mass of 81 kilograms, plus the mass of the average barrel, 22 kilograms, and divide that by 1.17 seconds. Gives you 109,778.6 newtons of force. That's one hell of an arm. And I'm pretty sure a human bullet is dead, as he would have to survive about 108 Gs of force, well over double the amount a trained fighter pilot can survive for a brief period of time. And that's it. Go watch Attack on Titan.